So hey guys, welcome back to my channel. Hope you're doing extremely well. This is your very own mask coder, and today we are going to solve the 66th day POTD. And today's problem is game with string, and as you can see, it is coming in one of the great companies, Amazon. So let us look at the problem. But before going from the problem, I will keep my promise and explain the pre-order, in-order, and post-order traversals, right? And yesterday I posted a question, like I discussed a question in the video itself and asked you to comment the answers. So these are the two users, so big shout out to them that they actually replied. One of them was correct, one of them was incorrect, but the incorrect doesn't matter. What matters is your effort. I'm really impressed with these two guys. And if any questions come in the upcoming videos, please make sure that you also comment. Okay. So discussing about the traversals for the pre-order, post-order, and in-order, right? So I was going to tell you a trick so that you never miss any traversal. Always get it correct. For pre-order, for pre-order. Whenever you encounter a word pre-order, what do? You keep slashes on the left side of the nodes. Okay. And after you keep slashes, traverse from the left side only. Traverse from the left side only and keep drawing a line. So I keep drawing a line. I see it encountered this line. So my pre-order will first node will contain A. After that, it is going down, 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 encountered B. Second node will be B. After the down, 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 C. Third node will be C. After that, wrap it around, go here. You see, D is the fourth node, so D. Okay, wrap it around, go like this. E, then F. After wrapping it around twice, G. And you can see all the nodes are covered. So this will be your pre-order. Similarly, for post-order traversal, let me erase this line. Yeah. Yeah, for post-order traversal, you will keep your lines in the right. In the pre-order, you keep it on the left, and in the post-order, you will keep them on the right. Again, start traversing. Now traversing not from the right, only from the left only. Here also it will start from left. Okay. Wrap it around C. All right. Wrap it around D. Then B. Come, and you will counter F. After that wrapping, and then G, then E, then A. So it will be G, E, A. This will be your post-order traversal. For the in-order traversal, you have to do like in pre-order you encountered on the left, in the post-order you encountered on the right. In the in-order you will encounter it on the bottom side. Now I will not tell the answer for in-order, but you will have to tell me the answer in the comment section. And those who will try to get the answer correct, I will give them a shout out like these two. Big shout out, guys. Big shout out. Appreciation. Okay. So let us not waste time and solve today's problem because we also have to maintain a streak and we have to keep moving towards our goal. So today's problem is game with string. So the problem says that you have been given a string, right? Suppose the string is AAA, BB, C, D, 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 D. Okay. And you have been given an integer k. The problem demands you to remove exactly k characters, exactly k, right? Exactly k characters. Remove, okay, such that the value becomes minimum. Value becomes minimum. Now, what is the value? Value is sum of squares of count of distinct characters. That is distinct characters. Also, the I have given you a pretty that all the words are clustered together, all the similar words. The question doesn't say anything like that. The words can be jumbled up also. Okay. Sum of squares of count of distinct characters. That is, you can see A is occurring 3 times, B is occurring 2 times, C is occurring 1 times, 4 times, D is occurring 4 times. Okay. So the current value before removing the k characters, it is 3 square, that is count of a square plus 2 square plus 1 square plus 4 square, that is equals to 9 plus 4 plus 1 plus 16, which will give rise to 25 plus 5, 30. Okay, this is your current value without removal. After removal of k characters, get another value, correct, and you have to make it minimum. The logic here will be to minimize it. To minimize it, I will have to decrease what? Like I in the above question, suppose my k is 1, right? Suppose my k is 1. So what should I decrease? Which value should I decrease? Should I decrease 3, 2, 1, or 4? Which value should I decrease such that the value becomes minimum? I only have to remove one character. So if I remove 3, it will become 2, it will be adding 4, it is currently adding 9. Difference of 5 will be made. If I remove 1, 2, then it will be adding 1, and it is currently adding 4, so it will make a difference of 3. If I remove 1, it will be adding 0, and is adding 1, it will be making a difference of 1. If I remove 4, it will be adding 9, 3 square, and the difference will be of 7. So you can see the maximum difference is coming from the maximum value. Obviously, it is very true that a square is less than a plus 1 square, right? And the difference continues to be greater. That is, if you write on the squares, that is 1, then 2 square is 4, then 3 square is 9, then 4 square is 16, 25, and then 636, 49, 64, correct? So it is difference of 3, then 5, then 7, then 9, then 11, then 13, I guess, yeah, then 15, yeah, 15. So you can see the difference is increasing. The difference is 3, then 5, then 7, then 9, then 11, then 13, then 15, right? So the more the large number is, I will have to remove that. Okay, but in this case the k was 1. Suppose if k is 3, okay, k is 3. So in the first step you will remove 1, 4, it will become to 3, right? Now 3, 2, 1, 3. You have got it to 3 as 2 now, right? After that, what will you remove now? You can see the maximum now is 3, 2, 1, 3. That is maximum also 3. Okay, removed it once again. 2. Now you have to remove only one character, right? Because you have already removed 2. Now to remove that one character, you will also again find the maximum. Mark my word, again find the maximum. Again find the maximum. This is what I'm using again and again, right? This will be a core concept. Again find the maximum. So it is 3, 2, 1, 2. What is the maximum? It is 3 now. So make it 2. So our answer will be 2 square plus 2 square plus 1 square plus 2 square. That will be equals to 4 plus 4 plus 4, that is 12, plus 1, 13. That will be your final answer. This will be the minimum value for your answer. Now your homework is to determine if there is any other possible value that is minimum than this value, and challenge me in the problem. Okay. Okay. So what was our algorithm? Our algorithm was that count the number of distinct characters. Maintain a count, right? Maintain a count, right? This was the first step. In the second step, for k number of times, for k times, decrease the maximum count by 1. That is what we were doing, right? We were decreasing the maximum count by 1 only, the maximum count, right? After that, third start was, after k number of times it happened, calculate your answer. Calculate your answer by, how can you calculate your answer? By summing the squares of counts. Right? This was an algorithm which we were using to find out the answer, correct? Okay. So, how can I do this? This can be done easily using a map correctly. So it will be using O(n) time complexity and O(n) extra space. Okay. Now this will be running k times, and we have to decrease the maximum count by 1. But to decrease the maximum count by 1, I will have to find the maximum count, and that will take me O of n time, right? It will take me O of n time. So n not, it is p. Let us say p is the number of distinct characters. P is the number of distinct characters, because n is the total length, right? P is the number of distinct characters. Okay, hope you are understanding that. Okay, decrease the maximum count, so it will take me O of p. So all in all, this second step will take me O of kp, no space complexity obviously, and then last step will take me O of p again, right, because of squaring. So what is my total time complexity? It is O of n plus O of kp plus O of p, correct? Which will be equals to the maximum of all these. So it will be maximum of this and this. Whichever is maximum, take that one. All right. Now, the brute force is clear to you. This is the brute force, guys. This is the brute force. Can we optimize it? Yes, here comes the catch. I was saying that you should note again find the maximum, again find the maximum, again find the maximum. Can we use a data structure defined for that? Yes, we can do. Here comes a concept of heap, which is also known as priority queue, right? What is the function of priority queue is whenever we insert an element into the priority queue, whenever we insert an element into the priority queue, it gets inserted such that the priority queue remains sorted. So as in, if my priority queue is containing 2 3 5 7 9 and I'm willing to insert 4, it will neither get inserted here or here. It will go against all odds and get inserted here. But the time complexity to insert in a priority queue is O of log, let us say the size is n here, so O of log n. Okay, so can we use that? Okay. Now priority queue is also of two types: a decreasing priority queue and increasing priority queue, which is also known as min heap and max heap. So in one priority queue, we can keep a maximum at top, like it is simple queue. So queue also we use a what do we say? A top element, right? A front element, right? So either we can extract the maximum element or the minimum element. But in this case, we will be requiring a maximum element because the reasons I shown above. I don't think that repeating them is necessary. So what I will do is my new algorithm would look something like: first step would be same, generate a count, right? This will be same. I will be using a map O of n time complexity, O of n space complexity. Nothing changes in the first step. Now the second step says put all the counts in the priority queue. Okay. Now my third step says for k number of times, what you have to do, take the top element out of priority queue, top element out of priority queue. Okay, that is, take it and then pop that element out of the queue. After that, decrement it. Okay, because we are removing, so we have to decrement the count, right? Then push it into the pop, push it into the pop, into the pq, sorry. Why push it? Because as we seen in the dry run, when 4 was decreased to 3, 3 was again considered for removal, right? It was again considered, then only it became 2, right? So we have to again consider it, so we are moving it again into the priority queue. Okay, and fourth step also remains the same, that is the last step: compute your answer by summing up the sum of all the elements into the priority queue. Okay, now this step is taking O of n time complexity, O of n space complexity. This step is taking O of what do we say? Let's say O of n log n time complexity plus O of n extra space, right? Now this loop is running O of k times. This step is taking O of log p time, right? And this will also be O of log p, sorry, of log p, p log p, right? And p extra space only. Okay, because you're storing the counts only. Count is also the of the distinct numbers. Okay, so decrement it will be taking only one step and push it into the priority queue again of log p. It is taking logarithmic part in inserting or inserting. Sorry, this will not take O of log p. This will only take O of log p because removal is one step process. Sorry for my mistake. This will be taking O of 1 only, and then answer will take me O of what do we say, p, because of removal of the elements, right? So what is my total time complexity now? It is O of n, O of p log p. Now O of k into O of log p, that is k log p. and O of P, right? So it will be maximum of N or K log P, which is much better than what we discussed above, which was O of N with KP, right? KP. P has converted to logarithmic. That is a huge advancement, right? So we have discussed the pseudocode, right? Let us discuss the dry run. So I will be taking an example given here only. So A, B, triple C, right? A, B, triple C, right? And we have to remove only one character. So it is a fairly easy one. What will I do? I will generate a map. Let me say my map is this one. Map will give me A as 1, B as 1, C as 3. I will make a priority queue out of this map counts. So my priority queue would look something like, first I will insert 1, okay. Then I will insert 1, okay. Then I will insert 3, okay. Okay. Now for k equals to 1, like it will run the loop one time. So one time what I have to do is I will take out 3. 3 is deleted from here. 3 is comes to me. It is changed to 2, okay. Now 2 goes back. Now 2 also goes back in sorted order, which is here only, right? Okay. After that, I compute my answer. How I'm computing my answer? It will be 2 square, pop that out. 1 square, pop that out. 1 square, pop that out. Right? This is my answer. That will be 4 plus 1 plus 1, that is 6. And if we check the given example, it is giving us 6 as our output. So without wasting any time, let's code it down. Hope you got the pseudocode, hope you got the algorithm. There was no problem. And if a problem persists, you feel free to comment or get me on Insta DMs or get me on Discord channel. So sorry to say that you are not coming on my Discord channel or on my Insta. Please guys, I will not be able to update you guys if I'm going to do anything different than that. So please, like you are helping me in my YouTube journey, please help me in my Instagram as well as in my Discord channel, and hope the connections will work more, right? So let's just see what can we do in the coding area. So what are we doing? Our first step was to create a map to store the counts. So I'm creating a char in type of map. I will run a loop for int I equals to 0, I counts to s dot length, that is the maximum index I can go to, right? Now mp of si plus plus, simple. This will maintain the count. Okay, now I will make a priority queue, which is very simple. What I have to do is priority queue of type int, because I'm storing only the counts. I'm not storing the corresponding characters because I don't need them. Name it as pq. Now for int, for auto 8, because I have to traverse the map now, right? For auto 8 and mp, if it dot second is not equals to 0, right? If the count is greater than equals to 0, in that case what do you do? Pq dot push it dot second, right? I have the count in my priority queue. Now the third step was to run the loop k number of times. That is for int I equals to 0, I goes up to k, I plus plus. What were we doing? We were extracting the value out of the priority queue. So for that we will be using pq dot top, and after extracting we will remove that element from the priority queue, decrement the element, and then push it back. I will only push it back if it is greater than 0, because if it is not greater than 0, then it is no way, no use of pushing it back. So if a is greater than 0, only then pq dot push a, right? This will be happening k number of times. After that, take your answer as 0. Now while my pq dot empty, if it is not, it is returning 0, that is priority queue is not empty. What do I have to do? My answer will be equals to answer plus pq dot top star pq dot top. You can decrement the time complexity here used by using, taking a variable like here and in doing a into a, then pq dot pop, yes. And then at last, the most important step of an algorithm, to return the correct answer. So let's see if it is working fine. So in the meantime, please subscribe to my channel and hope you are liking the video. Hit the like button and do engage in the comment section. I have introduced some new questions in the starting of the video. Please watch them and do comment your answers, right? Because you will get a shout out from my side and a lots of love. Thank you. Have a nice day and keep coding. We will see you tomorrow. Till then, hustle hard.